Hey students, in this video we're going to cover inverse trigonometric functions. These are our objectives. So let's do a recap of sine and cosine. They are defined on the unit circle. So the output values are somewhere between 1 and -1 inclusive, any value between those two. And of course, the domain is any angle we can think of has a sine or cosine value. So in this lesson, we're going to cover inverse trigonometric functions, which are just the inverse of the trig functions that we know, sine, cosine, and tangent. Also the secant, cosecant, and cotangent, but we're only going to focus on sine, cosine, and tangent. So what do inverse trig functions do? They answer the question, what angle or what angles have this trig value? If we had like arc sine of a half, that's asking you what angles have a sine value of a half. And if you know, remember on the unit circle, sine is going to be positive in quadrant 1 and quadrant 2. So if we draw our little unit circle, we have pi over 6 right here. And the angle that uses pi over 6 as a reference angle in quadrant 2 is 5 pi over 6. So, go back. So 5 pi over 6, or this is the same as 150 degrees. And pi over 6 is the same as 30 degrees. So any angle that is coterminal with either one of those angles has a sine value of a half. And so this is why it's important that we have restrictions. Like right here, I put without restriction, we can just keep going around the circle. We can just keep adding 360 degrees. And there are an infinite amount of angles that have a sine value of a half. So an inverse trig function is going to tell you one of those angles, exactly one of those angles. And the whole purpose of this is to set up for us solving trig equations and application problems that involve trig, so we can understand what the angle means in context of the problem. So the arc sine function is the first of the functions that we have. If we look at the graph to the right, we can see that in terms of input values, the graph starts at -1. And if we trace it, we end at x equals +1. So that's going to mean that our domain is from -1 to +1. Now, again, if we go back a slide, 2 slides, we see that the range for sine and cosine is -1 to 1. But the domain for the inverse sine or arc sine function is -1 to 1. And then the range, now range again is from low to high. So we start at -pi/2 and we end at +pi/2. So our range is going to be from -pi/2 to pi/2 inclusive. Again, the reason that, now if we look at our unit circle, -pi/2 is down here. And then if we just trace the unit circle until we get to +pi/2, we've taken the first half of the unit circle or half of the unit circle without repeating any y value. That is why we restrict the inverse sine function to be from -pi/2 to +pi/2. Now, again, if we could go around the unit circle hundreds of times and keep getting angles that have a sine value that's between -1 and 1. But just like if you have the square root of 4, it could be 2 or -2, then that's going to create a problem if you need to refer to a specific value. So generally, we restrict the inverse trig functions to be on a particular range to avoid multiple outputs. So in the case of sine, that's going to be -pi/2 to pi/2. Now for arc cosine, if we look at the graph, we see that the domain is still from -1 to 1. So our domain is still -1 to +1. And the range is, we start at 0 and go up to pi. If we look at the range, so we go from 0 to pi. So now if we look at the unit circle, remember cosine is an x value. So in order to not repeat x's, you have to start at 0 radians and go around the unit circle until you've taken on every possible cosine value. And so that would take us from 0 radians to pi radians, or 0 degrees to 180 degrees in terms of if the angles are in degrees. So our range for the inverse or arc cosine function is 0 to pi. And now we have a quick check. Remember that the arc sine or arc cosine functions answer the question, what angle has this cosine value or sine value? And again, right now we want to give our answers on the interval 0 to pi for cosine, or negative pi over 2 to pi over 2 for sine. Oh, go back. All right, so if you pause it and came back, arc cosine of a half, that is going to equal the angle that is pi over 3, or in degrees, that's going to be 60 degrees. Arc sine square root 2 over 2 is pi over 4. In degrees, that's going to be 45 degrees. And so now we have arc cosine 11 pi over 6. So if we draw we'll draw a little unit circle. So 11 pi over 6 is in quadrant 4. So if the angle's in quadrant 4, that means cosine is positive. So the cosine of 11 pi over 6 is going to be, we're going to rewrite this so that we have arc cosine. So the cosine of 11 pi over 6 is square root 3 divided by 2. And since arc cosine gives us angles between 0 and pi, then this angle is just going to be the reference angle, that is pi over 6. So that is how we do a nested. We have a trig function inside the arc cosine, find the inner trig value, and then find the angle that has that trig value. For number 4, we have the sine of arc cosine negative 3 over 5. So cosine is negative, right? So let's see. And we want to find the sine of that angle. So cosine is negative. It means that the angle has to be in quadrant 2. So it can be in quadrant 2 or quadrant 3, but we'll see what that means in a moment. So cosine is negative 3 over 5. So this is going to be our negative 3, and the hypotenuse is going to be 5. If we did the Pythagorean theorem, we get the vertical side is 4. So if this is our theta that we use as a reference angle, then what we're asking, what is the sine of an angle that has a cosine of negative 3 over 5? Well, remember, sine is going to be defined in either quadrant 4 or quadrant 1. The arc sine function is. So in this case, that's just going to be positive 4 over 5. Now, if we change our restrictions, which we'll see in a later slide, we could also get this angle that's in quadrant 3, but we'll talk about that. So in this case, it's going to be 4 over 5, because if cosine is negative, that means that the angle is in quadrant 2, and then that means the sine is going to be positive. So that means using the reference angle, we're going to use what's in quadrant 1, which will give us positive 4 over 5. The tangent function. So we have not talked about the graph of the tangent function. It is here below. If we extend our number line, we'll say this is negative pi over 2, and we'll add a vertical asymptote here. So if we continue the graph of tangent, notice that from negative pi over 2 to pi over 2, the graph is the same as from pi over 2 to 3 pi over 2. Since tangent x is sine x over cosine x, or sine theta over cosine theta, we have a ratio. And so that means that we could end up dividing by 0. So tangent is defined where cosine x is not equal to 0. And so remember, cosine is an x value. So cosine is 0 on the y-axis. And that's going to be the angle is pi over 2. This angle is 3 pi over 2. The first coterminal angle is going to be 5 pi over 2. The next one is 7 pi over 2. Then we get 9 pi over 2. Then we would get 11 pi over 2 and so forth. So when we say that theta can't equal pi over 2 plus k pi, it's just any angle that isn't an odd multiple of pi over 2. So that's the domain, is any angle that is not an odd multiple of pi over 2. Next is the range. As you can see, the graph starts low, goes all the way up to infinity. So negative infinity to infinity is the slope. Is the range. And remember, tangent is the slope of this angle. It's the slope of this line segment here. So when we say the period is pi, the reason the period is pi is that whatever angle is made, like say in quadrant 1, then the line could carry through quadrant 3, and the slope of the line in quadrant 3 is going to be the same as the slope of the line in quadrant 1. And so obviously a straight line makes a straight angle, which is 180 degrees. So every 180 degrees or pi radians, you're going to start over the tangent function because you're going to repeat tangent values. So now, again, we just need to know these two pieces of information primarily so that we can get the inverse tangent function. And so the arc tangent or inverse tangent function is just the inverse of tangent. The domain is negative infinity to positive infinity. And again, to avoid redundancy or repeating angles, we restrict the range to be negative pi over 2 to pi over 2 because that's when the graph starts over. And so that's why the range is negative pi over 2 to pi over 2, not inclusive, because the cosine of negative pi over 2 and pi over 2 is 0, and we cannot divide by 0. So now another quick check. This requires that you know the unit circle, that you memorize those values, or you have that reference thing handy. Arc tangent of pi over 3, you should get, not pi over 3, square root 3, you should get pi divided by 3, or in degrees, that's going to be 60 degrees. Arc tangent negative 1. So remember, arc tangent is defined from negative pi over 2 to positive pi over 2. So if the value is negative, it's going to be in quadrant 4, which means we need the negative of one of those quadrant 1 angles. So that's going to be negative pi over 4 or negative 45 degrees. The sine of an angle that has a tangent of negative 3/4. Let's see what that looks like. So tangent is negative in quadrant 1 and quadrant. Tangent is negative in quadrant 1 and negative in quadrant 4 and quadrant 2. So let's assume that so arctangent is defined in quadrant 1 and quadrant 2, or for angles that are from negative pi over 2 to positive pi over 2. So we're going to draw our angle down here. So negative 3, and the hypotenuse is, the cosine value is 4. That's going to make the hypotenuse 5. So the sine of this angle is going to be, the sine is going to equal negative 3 over 5, because we're going to do the opposite divided by the hypotenuse. Now, again, the reason we didn't do this in quadrant 2 is that because arctangent is going to give us an angle in either this quadrant or that quadrant, we are assuming that the angle is going to be in quadrant 4 because tangent is negative. And so then we need to find the sine of that angle in that quadrant. All right, inverse trig values with a calculator is very straightforward. On a TI, you need to press first, second, and then choose the appropriate trig function to get whatever angle that you're looking for. Make sure if you're looking in radians, your calculator is in radian mode. To put your calculator in radians, choose the mode button and select radians. So if we're doing arc tangent -1/5, all you got to do is make sure your calculator is in radians, and we're going to do that. So we're going to do arc tangent or tangent inverse of -1 divided by 5, and I get -0.1974. So that equals -0.1974. I should mention that these two things are equivalent. Tangent inverse is the equivalent of arc tangent. They are exactly the same thing. It's just one way of writing the inverse. So then if we did arc sine -2/5, that's going to give us -0.4115. So that equals -0.4115, -0.4115. And then arc cosine of 1 divided by pi, I get 1.2469, 1.2469. So now we have to also give these in the nearest degree. So remember, 1 degree is equal to pi divided by 180 degrees. Or we can do 1 radian is 180 degrees over pi is equal to 1 radian. So we could also put the calculator in degree mode, but this gives us a chance to go back and practice that skill. So this is going to equal 180 degrees divided by pi times -0.1974. So let's see, 180 times -0.1974, enter, divided by pi. I get -11 degrees. So that's about -11 degrees. Now you could go back and put your calculator in degree mode and go back and do each of those inverse trig functions, which is what we'll do for the other two. But it's just, you can see that the conversion works however you want to do it. So let's see, if we did arc sine of -2 divided by 5, that's going to give us -24 degrees because it's 23.5. So -24 degrees, and arc cosine of 1 divided by pi is going to give us about 71 degrees. So you can either use the conversion or put the calculator in degree mode and just type it in. However you want to do it is how you do it with the calculator. This is what you can expect to see when you practice this on Delta Math. So we have to find all angles theta such that theta is between 0 and 360, and we know the sine of theta is -0.7. So first, let's talk about how we can make this into an inverse trig thing. So if sine theta equals -0.7, then this is true. Then arc sine of sine theta is equal to arc sine of -0.7. The arc sine function has this property, like the square root of x squared equals x, the square root and the square get rid of each other. The arc sine and the sine also eliminate each other. So we end up with theta is going to just equal the arc sine of -0.7. And let's see what that gives us in degrees. So arc sine -0.7, I get -44 degrees. That's about -44 degrees. So theta equals -44 degrees. So this is theta. The reference angle is going to just equal the positive version of that. So the reference angle is 44 degrees. That's the first angle. And so then the second, all right, so if we draw our unit circle, so we get our unit circle, right? Remember, sine is a y value. So sine is positive in quadrant 1 and sine is positive in quadrant 2. How do we get that quadrant 2 angle? 180 degrees minus the reference angle is going to be how we get that. So that's going to be 180 degrees minus 44 degrees is 136 degrees. So the angles that have a sine value of negative 0.7. Oh, I'm sorry. Sine is negative. I'm doing all of that and sine is negative. So we need these angles to be in quadrant 3 and quadrant 4. My apologies. So in quadrant 3 and quadrant 4. So then it's going to be theta plus the reference angle. So theta plus 44 is 224 degrees. So one angle is 224 and the other is, since the angle's in quadrant 4, is going to be 360 degrees minus our reference angle. And that is going to be, actually we can do, so negative 44 plus 360 is the same thing. We would do, what's that, 316 degrees? So 316 degrees. So the two angles are 224 and 316. So we have to first find the reference angle and use that reference angle to find the angles in the appropriate quadrant. For this one, we know that theta is between 0 and 2 pi. Tangent theta is equal to 3. So first, we're going to do arc. I can spell arc tangent of tangent theta is equal to the arc tangent of 3. So theta is arc tangent of 3. Make sure your calculator goes back to radians. So we're going to round this to 4 decimal places, and we're going to get tangent inverse of 3 is 1.249. We get a 0, so that's not going to round up. So 1.249. We're just going to put radians to know that we're not using degrees. All right. So 1.249 radians. Fantastic. So pi 1. Let's see. So just as a reference, in case you don't know, pi divided by 2 is like 1.57 something. 1.571. So is 1.571. So what that means is that we already have the reference angle. So if theta is 1.2, so remember 90 degrees is pi over 2. So theta, we'll say like this is theta equals 1.249 radians. Cool. So that means we already have one of the angles between 0 and 2 pi. To find the other angle, we're going to be in quadrant 3. So to get that quadrant 3 reference angle, we want to do pi plus theta equals the quadrant 3 angle. And since theta is 1.249, we're just going to do pi plus 1.249, which is, who knows? And that's going to be 4.391. So 4.391. Now, if you wanted to check this in your calculator, you can just do tangent of 4.391. And let's see what we get. Tangent 4.391. And we get, this is roughly 3.0036. So it's very close to what we started with. All right, and so the last thing that we're going to do is we have to find the reference angle, which is what we did on the previous 2 slides, and also state the 2 quadrants in which theta could lie. Now, again, this is going to be assuming we're going from 0 to 360, 0 to 360, or 0 to 2 pi. One of those things. So first, we're just going to do Theta is sine inverse of square root 34 divided by 8. And who knows what that is? Make sure your calculator goes back to degree mode. So sine inverse square root 34 divided by 8. I get, this is to the nearest tenth of a degree. This is 46.8 degrees. All right, so now if sine is positive, then remember sine is a y value. So sine is positive in quadrant 1 and quadrant 2. So our reference angle is the reference angle is 46.8 degrees, and theta could lie in quadrant 1 or quadrant 2, and that's because sine is positive in those quadrants. All right, so quick recap is we have the arc sine function, domain is -1 to 1. Arc cosine function, domain -1 to 1. The range for the arc sine function is -pi/2 to pi/2. The range for the arc cosine function is 0 to pi. And then for arc tangent, the domain is from -infinity to pi to infinity. And the range is -pi/2 to pi/2, exclusive, not inclusive. And you can see the graphs for each one of those. And the last thing is these three functions are interchangeable with arc sine, arc cosine, and arc tangent. They mean exactly the same thing.